Here is another example using hypothesis testing. So it is believed that 47% of males at Mesa College go to the gym. So a researcher claims that there has been a change of the proportion who go to the gym. Okay, so 100 male students are selected and 45 say that they go to the gym. So what can you conclude at a 10% significance level? So this time I did put my alpha in there. Okay, so the first thing that we want to do is we want to write our null and our alternative hypotheses. So let's first start off by writing H0 and also HA. So notice that we're still dealing with proportions. You see that the word proportion is constantly being thrown around. So we know that this should be a P here and a P here. Now we want to think about this. Remember, this is always going to be equal to. So what is believed in the very beginning? So it is believed that 47% of males at Mesa go to the gym. So that's basically what we know from the very beginning. So we are establishing this as a truth. This is what we believe. Now, what are we really claiming? So what is this researcher trying to figure out? So a researcher claims that there has been a change of the proportion who go to the gym. Okay, so a change. So is it very specific in terms of, does it say increase, decrease, or is it just really, really vague? So you can see that it's really vague. There's not a lot of, it's not specified whether there's been an increase or a decrease. So because there's no really specification of what that is, we're just going to say not equal to. Okay, so if you read a problem and it doesn't really say increase or decrease, or you can't really tell, it's probably going to be not equal to. Okay, so a change, a difference, we don't know if that's increase or decrease, so we're just going to say not equal to. It can either be an increase or it can either be a decrease. Okay, all right, so that's basically all it is for the first one. Okay. So now part B says find the test statistic. So the test statistic formula is Z is equal to P hat minus P divided by the square root of P 1 minus P over N. So I'm going to write first our P hat. So remember, our P hat is our data. So that comes from our data. So what data did we collect? So this researcher collected from 100 people, or 100 males, 45 said that they go to the gym. So my P hat is going to be this 45 out of 100, which is 0.45. So your P hat is going to be 0.45 minus, and now we're going to write our P. Our P in this case is going to be this 0.47 divided by the square root of 0.47, 1 minus 0.47 divided by N. And in this case is going to be the number of people that we selected, which was 100. So now let's put this into our calculator. We get second data, not second data, fraction 0.45 minus 0.47 divided by the square root of 0.47 times 1 minus 0.47 divided by 100. And I ended up getting negative 0.40. Okay, so just, that's what I get. So 2 decimal places. So I got a negative number, so a negative z-score, so that tells me that it's below the mean. Okay, so now we want to know, is this z-score unusual or not unusual? Well, not really. It doesn't look very unusual. So already right off the bat, we can kind of say, I'm probably not going to reject this. Okay, it's not really large. It's not close to -2 or 2. It doesn't surpass that. So we can already decide, oh, I don't think this is really unusual. So now part C. Is this a right, left, or two-tailed test? Okay, so remember that is decided on the alternative. So let's look at the sign or the inequality on the alternative. You can see that it's a not equal to. A not equal to means that it's a two-tailed test. So it's two-tailed. You'll see why I asked this question, because there's going to be a difference in the p-value. So now that we know that it's a two-tailed test, part D says find the p-value. So remember, where is the p-value? So we know that the p-value is just found by normal CDF. We're going to find the lower bound, the upper bound, the mean, which is still the same, is still 0, and the standard deviation is still the same, is still 1. Okay, that never changes. So the p-value, well, let's see where the p-value is. So because we know this is a two-tailed test, we know that we're going to have two different p-values. We're going to have one over here, and we're going to have another one over here. Okay, so it's just sufficient to just find one of them, and just once we find that one, just multiply it by 2 because there's going to be two of them. So now we need to figure out which one did I just find, which test statistic. Was it the one over here or was it the one over here? So let's go back up. It's negative 0.4. Because it's negative, it's going to go over here. So if you kind of think about, well, the mean is 0, so that means this middle part is just going to be 0. You can see that negative 0.4 is going to be over here. So let's find the p-value over here, and then later on multiply it by 2 so then I can find the other p-value. Okay, so now remember over here it's negative infinity. So this is just going to be normal CDF. My lower bound is going to be negative infinity. My upper bound is going to be negative 0.4. My mean is still 0. And my standard deviation is still going to be equal to 1. Okay, so let's go ahead and put this in my calculator. So normal CDF, 0, 1. My lower bound is negative infinity. My upper bound is going to be negative 0.4. And I'm going to get 0.3446, around that area. Now notice, this is not the answer, because this p-value right here, this guy, only corresponds to this area. How many p-values do we have? We have 2 of them. We also have this guy. So what we're going to do is you can either add it to the same thing or you can just multiply this by 2. So I'm going to multiply that p-value by 2. So 0.3446, multiply it by 2. Equals 0.6892. So this is my p-value. This is the answer. So you might be wondering, when are we going to multiply by 2? The only time that you multiply by 2 is when you have a two-tailed test. Okay, so if you want to write it in your notes, two-tailed test means multiply the p-value by 2. All right, so now part E says, what is your decision? Okay, so I know my p-value is 0.6892. My alpha value, which is my significance level, well, let's see what that was. So if we go back up, my significance level was equal to 10%. 10% in this case is 0.1. Okay, is the p-value small? No, the p-value is not smaller than alpha. So it's not smaller. Okay, so can we reject? No, cannot reject. Or we can say fail to reject. So remember, we only have two decisions. We can either reject or fail to reject. So in this case, because this is not smaller, we're just going to fail to reject the null hypothesis. Okay, so which is kind of what we kind of thought in the beginning. We saw the z-score and said, well, this isn't close to -2. It's pretty small. So we're probably not going to reject this. And this p-value gives us the actual reassurance. So now what can you conclude? So we failed to reject. So do we have enough evidence? Notice that in the previous problem, we said we had enough evidence because we rejected. Here, since we failed to reject, we say we do not have enough evidence. So we do not have enough evidence to say what? To say that, well, let's think about what my claim was. So if we go back to the problem, so what were the researcher thinking? He was trying to claim that there has been a change in the proportion. So all we can just say is that we don't have enough evidence to say that there has been a change. In the proportion of men who go to the gym at Mesa. Okay, so that's basically the gist of it. So problems like this will be very similar. You just have to be able to break up the problem and get the information that you need from it. But everything else is things that we have done already in this unit. We know we're still doing normal CDF. Okay, we're still doing z-scores. We just have an additional layer in the very beginning. We have the null and alternative that we got to do first. We know how to calculate a z-score. We know how to calculate a p-value using normal CDF. So we've done that. And then you have this other layer of comparing your p-value and your alpha. and then also concluding what that is.